Okay, Assalamualaikum class. So previously you have learned about DC analysis of diode. So let's move to the AC analysis of the diode for this chapter. Okay. So in your chapter 2, you learn about semiconductor, how you analyze the diode in the DC analysis. What is the load line? Load line is when you have the IV characteristic. This is the IV characteristic of the diode. The straight line here, what we call load line. Why you need to have load line? Because you need to have the Q point. Okay, and now we move to the AC analysis of diode. So when talking about AC analysis, you are expecting to have the source of AC source. Okay, so let's recall back the keywords. So drift and diffusion is two types of the current. Junction capacitance happen during reverse or forward. It happen during reverse bias. Diode current happen during forward bias, and you have built-in potential. What is IV characteristic? Is the current and voltage characteristic. If it is for diode, so you have here is forward bias, here is reverse bias. Okay. And these are all the formula that you learned previously. This is happen during forward bias where you have current. During reverse bias, you have the junction capacitance. And what is built-in potential is the minimum voltage required to break the covalent bond, right, to get the current. Okay, and when you have a diode, so here will be positive, minus, and the current will be flowing inside from the P junction. Okay, so for today, we will learn about AC analysis of the diode. So what is actually AC analysis? Now let's recall back DC analysis. Your aim is you want to find the Q point. Why you want to find this Q point? What is the Q point? Is the ID and the VD value to turn on the diode, because diode is an active component. Now, why you need to do AC analysis? Because you know, in diode, it allow current to flow in one direction, right? So if you having the connection of an AC voltage at the input before the diode, so you are going to get the point of ID, AC current, and small d, diode voltage at the AC. So this one will be go to the RL. So this is VD, and you need to find the value of output here. So this is denoted by small v, small 0. So this is all about AC analysis. So when we have AC analysis, do you still need the DC supply? The answer is yes, because remember, diode is an active component where you need some DC voltage to turn on the diode. So what is the minimum voltage to turn on the diode? Let's say your built-in potential is 0.7. You need to have minimum 0.75 or 0.73 to turn on the diode. When we are talking about AC analysis, we need to have additional voltage source, that is AC source. So this is an AC source, this is a DC source. So if you recall back the first chapter, you have this equation. Small and capital letter here, what we call total. Total current or total voltage at the diode. So total current or total voltage will be equal to this, let's say this is total current, will be equal to the DC current plus AC current. How you denote total current? This one is small and capital. DC current, everything must be capital. AC, everything must be small. Can you interchange it? No, because the capital and the small letter need to be correct. So when you do DC analysis, you're going to focus all capital. When you do AC analysis, all your notation need to be small. And your source need to have one DC and one AC. Okay? Okay. So with that, when we have two voltage, one is AC, one is DC. So this is the equation that you learned last class. So you have the diode current. So if you look at this notation, this is neither DC nor AC. It is a total current. So when talking about total current, here is also will be total voltage. So you're going to expand this total to become DC and AC. So that's why this VD here, VD total equal capital D capital V plus small VD. So this is AC, this is DC. Okay. So when you expand this exponent, it become multiply. So you have E power of this DC and another exponent power of this AC. Okay. So the the orange color here will denote as the DC current. So you can denote this one. The whole here become IDQ. IDQ. So how you write the equation? So it become the total equal IDQ exponent small v small d divided by Vt. Now how you going to expand this E power of Vd over Vt? According to the linear series here, you're going to denote that one to become 1 plus Vd over Vt. So it be like this, it become 1 plus Vd over Vt. So let's see what will happen next. So this is the total and you have IDQ 1 plus Vd over Vt, same with this previous equation. So now you need to expand this one. So it become IDQ plus IDQ over Vt. This is the expansion and Vd. Okay. So this is a DC current. The whole here is actually become the AC current. So you know ID total equal IDQ plus ID. So this ID is actually denoted by what? Denoted by the whole equation here. Because this one is DC, right? So you can denote ID equal IDQ over Vt multiplied by Vd. Now what is the relation that we need to find? You need to define I and V. You need to relate it to become resistance. So you know R by Ohm's law, R equal V over I, right? So this is Vd and ID. So you just bring this one down and then this one you go to the other side. So it become Vt over IDQ. So this is the final equation that we want during the AC analysis. Your RD is equal to what? RD equal the thermal voltage 0.026 divided by the DC diode current. So this is a resistance, small resistance denoted by RD. So during AC analysis, you are going to equate your diode to become RD. So let's say you have a diode here. During AC analysis, change your diode to a resistor. This resistor is called RD equal Vt over IDQ. Where can you get this IDQ? From your DC analysis. Okay. So the original circuit is having two sources. So when you know that you have multiple sources, you need to use superposition, where you need to turn off once. Okay. So let's say we make it here VPS active, the DC supply. What will happen to the VI? Will be off, means you're going to turn off, means shorted. Now, in your diode, you're going to replace either, depend on the question. If it is PLM1, so you're going to replace with V gamma. Okay. If PLM2, V gamma series with RF. But for your AC equivalent, you're going to turn off this VPS and you only have VI. But at your diode, what you're going to replace is what we call RD. What is RD? Vt over IDQ. Okay. So these are the steps. First, you need to draw the equivalent circuit. Your circuit consists of two sources. So when you start to analyze, you need to have only one sources. DC analysis, you need to turn off the AC source. AC analysis, you need to turn off DC source. Okay. Back to the DC analysis, your aim is what? Your aim is you want to find IDQ, the diode current at the DC analysis. So you're going to choose which model, depend on the question. If the question given V gamma and RF, you know that you need to replace with model 3. Once you got the value of ID, replace this equation to have the AC analysis here. So your RD goes to AC analysis. So at your AC analysis, you only have the AC source, where the DC source you're going to turn off. Replace your diode with RD and calculate the current. Denote here, AC is a small letter, DC is a capital letter. Okay? Okay, so let's do one example. The circuit will remain the same. What you need to find is the DC voltage and also AC voltage. So let's start with the DC. You know, when you're doing DC, you need to turn off your AC sources. So it becomes only VPS. And then you have your diode, your R. And the current flowing here is capital I, capital D. Now let's see the question. It gives you only V gamma. So you know this is PLM1, not PLM2. So replace your diode with V gamma. Okay, then next, here is your V out, right? The question wants V out, the DC output voltage. So by using KVL, become minus VPS plus V gamma plus V out is equal to 0. And then you can get your V out is actually VPS minus V gamma. Okay? Okay, then you can get here is 5 minus 0.6 is actually 4.4 volt. So this is the value of your V out during DC analysis. So if we see the solution here, this is during DC analysis, you're going to replace with V gamma because the circuit is only having V gamma. So in this solution, find the value of ID first and then you can get V out. So this is the KVL equation. Minus VPS plus V gamma plus, what is the voltage across R? Is RID equal to 0. You know your VPS, V gamma, and you also know your R, and then you can get your ID. Okay? And then from there, you can calculate your V out according to Ohm's law. Now, what happened during AC analysis? You are going to turn off your DC supply by shorted it. And the current flowing here is not capital I, capital D. It becomes small I and small d. And at first, there is a diode, right? So you're going to replace your diode with RD. What is RD? VT over IDQ. VT is the thermal voltage. IDQ is the one that you calculate just now, 0.88. Then you can find your RD. So once you got your RD, you just use KVL minus VI plus RD. So this one must be small letter because this is AC plus R small I small d equal to 0. So then you can get your ID equal V in divided by RD plus R plus R. Okay. So what is your VI? So VI must be in sign because this is AC voltage. That's where this is in sign. RD is the value that you calculate just now plus the load resistor. So your answer will be in sign, and don't forget to put the unit microampere. But the question wants you to find V out. So just use Ohm's law. Just multiply this one by 5 kilo ohm, and then you can get the final answer with voltage. So remain your answer for AC with the sign output. Okay, because this is AC voltage, the output also must be AC. Okay. Okay, so there are more examples here. So you can see in the slide. So try to make your time to solve this question. What is the keyword? Number 1, start with DC analysis where you're going to turn off AC source, right? And then you're going to do KVL to find capital I diode current at the DC. Once you got your diode current, you find RD. Why you need RD? Because this is the value for AC analysis. And then you turn off the DC sources for you to run the AC. And then you do again the same KVL to find small I, small d. Okay. Same with this example. And you can get your final V out. So I have a few examples here. So I hope you can try by yourself. And this is what we learned inside chapter 2. So we have another video for multiple diode after this. Okay class. Assalamualaikum warahmatullahi wabarakatuh.